just fade up on the fact that, it's very hard to find a topic to fade up on for your podcast.
That is true.
I'm always looking for good fade up topics, but because you want to sound like you're actually talking about something interesting when people tune in. Right, okay. So, I'm Tim.
And I'm James.
And you're listening to Quasicast. And we've had a bit of a break with this. It's been quite a long time since we did the last one before Christmas and all the crazy things that have happened in the world since then. So with the world going totally crazy, we're going to talk about a crazy subject. We're going to get out our tinfoil hats and our radio antennas and spinning discs, and we're going to risk talking about alien life.
Yes, or the lack thereof, potentially.
Or potentially the lack thereof. Indeed, we're going to kick off by talking about an article that has generated a bit of buzz in the press at the start of this year. It was published at the very beginning of January in the journal Astrobiology. And it had a bit of fame on social media when the press release that was used to announce it was supposed to read... New Oxford University study concludes that intelligent life is rare in the universe, but accidentally printed New Oxford University study concludes that intelligent life is rare in the university. And we'll be debating which one of those summaries of this paper is the more accurate.
Yes, very ironic. Okay, well, do you want to summarise briefly what this paper claims to have discovered?
Yeah, okay, so the title of the paper is The Timing of Evolutionary Transitions Suggests Intelligent Life is Rare. So what it's trying to argue is that the authors of this paper, who are members of a couple of different Oxford University research groups, specifically the Mathematical Ecology Research Group and the Future of Humanity Institute, have applied some Bayesian statistical modelling methods to the data we have about the evolution of life on Earth, and specifically the steps that were required for us to evolve, for intelligent tool-using life to evolve.
Yeah.
And the conclusion, supposedly, of this statistical analysis is that the probability of life like us, intelligent life, occurring within the lifetime of our star, which I think is approximately, is it 10 billion years is what we estimate the lifetime of our star to be, I think?
Something like that, yeah.
So it approximates that there is a very, very low probability, fractions of a percent chance, that intelligent life would occur on a planet like ours within the lifetime of the star, and thereby concludes that Earth must be a tremendous statistical anomaly, and the vast majority of planets in the universe would not be able to support life, and therefore we are likely alone in the universe. That's the attestation of this paper. So, James, you're more knowledgeable about statistics because you know something about statistics. I'm basically totally ignorant on the subject, and it's pretty much the main area of your work at the moment. What do you think about the statistics that they've used here? Do you think that what they've claimed, the analysis that they've performed, and what they claim it can show bears any weight? Yeah,
well, I mean, what they're doing is performing a Bayesian analysis of a series of, well, they define to be independent events, and working out the overall probability of a particular outcome. And there's nothing inherently wrong with the analysis they've done. I haven't gone into great depth as to work out, do the derivations and calculations myself to verify them, but assuming that they have carried out the calculations correctly, the type of analysis they're doing is reasonable. But of course, as we'll come to see, it's only reasonable under the correct assumptions. Or, well, I should say that given their assumptions, I think we should assume that their calculations are correct.
So basically, mathematically or statistically, the paper looks right. Like it's not like this is some crazy, fringe group who are publishing total nonsense. Like the statistics and the distributions that they've used and the way they've described them makes mathematical sense as far as you're, willing to investigate.
Yes, I think that's a fair assessment of the situation.
But there's a problem with taking too much from that. I guess is what we're leaning towards,
Yes.
because so I'm sure I'll get angrier as we go on. But one of the phrases that occurred to me when I read this paper was a common phrase in statistics, which is garbage in, garbage out.
Yes.
Which is the idea that basically if you have a really, really good method for analysis, really sophisticated, uses very powerful statistical methods to analyze a set of data, it doesn't matter if your method is good, if the data you're putting into it is crap.
Yes, that's a fair.
And this is a big problem in a lot of fields of science that rely very heavily on statistical analysis. Especially, it's a very big problem in some areas of medical science, because if you have crappy data, it doesn't matter really what analysis you perform on it, you can't draw meaningful conclusions. And a lot of the problems that we hear about in terms of bad medical science are the result of this.
Yes.
A classic example that has had a huge impact on the world would be something like the anti-vax movement, where the statistical analysis that was used in the paper that first started off the anti-vax movement was not exactly wrong, but the data that was put into that methodology and the assumptions that were made about the relationship between data points in that data set were fundamentally wrong.
Yes, that's right. I mean, I guess we should clarify that, you didn't imply it, but just in case anyone does, is slightly confused, the paper itself was, not only was the fundamental data flawed, but the analysis itself was flawed as well.
And yes, of course, the conclusions and the way it was done was entirely flawed. But the point is that that was not some fringe paper published in a nonsense journal. That was published in the Lancet, I think, or was it the New England Journal of Medicine? I think it was the Lancet.
It was the Lancet because he was British.
It was the Lancet. So it was. It was by a supposedly legitimate academic, and it had the veneer of respectability on it, but it was nonsense. And it's a big problem in science, this veneer of respectability, where you have a valid or seemingly valid method, but assumptions and data and conclusions that are totally flawed.
Yes, well, I mean, arguably, I'd say that's the main source of error, right? Because often, the papers, well, I think you've just said this, but papers which are fundamentally flawed can hide behind this sort of technical approach, and I don't necessarily think this paper is an example of an active deception. I think it's more of a case of just fundamentally flawed premise, which is a shame. But I guess we'll get into that.
I think we should maybe start kind of justifying why we think the premise of this paper is flawed. And I mean, I understand, like you said, it's not as if this is purposefully deceptive, or at least as far as we can tell. But the argument about the Fermi paradox, which is the seeming paradox that, as far as we know, there is nothing special about the Earth. It's not particularly unique as far as we're aware, and we should therefore expect alien life to be common in the universe, and yet we observe no evidence of alien life. And it's one of the big questions of physics, and as a result, a lot of people have devoted a lot of time and energy to trying to come up with solutions to the Fermi paradox. And as happens in these very hyped fields, sometimes people just get a bit carried away.
Yes. So the core thesis of the paper is constructed on top of an a priori defined argument by another paper or another person called, well, I don't know what his first name is, but it's referred to in this paper as the Carter argument. Do you want to summarise what the Carter argument is, Tim?
But the Carter argument is an investigation of the relative probability of life occurring on different timescales. And the argument goes something like this. There are three possibilities for the average timescale over which intelligent life appears on a planet like the Earth. Either intelligent life could appear on such a planet over a timescale much less than the lifetime of the planet and its host star. Or the timescale for life to appear could be similar to the timescale, to the lifetime of the planet and its host star, or it could be much greater.
Yeah.
Now, within that window, if we assume that the formation of life and the lifetime of a star are completely independent, they don't share similar processes, so there's supposedly no reason to think that they would be linked in terms of their timescale. So if we assume they're completely independent, then we would assume that there is effectively an equal probability of the timescale for the formation of life occurring within any particular equal time window. But in these three possibilities, the three possibilities describe drastically different lengths of time. So it happening much shorter than the timescale of the lifetime of the planet and its host star is a relatively short window of time. The period where it's a similar length to the lifetime of the star is a longer period of time, and it being much longer than the lifetime of the host star, tens or hundreds of billions of years, is a very, very long stretch of time. So the argument then states that the chances of these two independent processes, the lifetime of a star and the formation of life, occurring over the same timescale is vanishingly small.
Yes.
And therefore life must evolve either at a timescale much shorter than the lifetime of the host star or much longer. And the argument then goes that, well, on Earth, intelligent life didn't form quickly. It didn't form, right after the Hadean period. It took 4 billion years to form. Therefore, the timescale for the formation of life must be, on average, much longer than the lifetime of a sun-like star, and Earth is just very lucky that it just happened that intelligent life appeared before the sun fizzled out and before the Earth was destroyed by its expanding photosphere.
Yeah.
And as a result, they conclude, and well, from this fundamental point, they then try to draw various arguments about the probability of different evolutionary processes, and then conclude that the likelihood of intelligent life existing anywhere else in the universe is vanishingly small. But there are big problems with this fundamental assumption. The key problem with the Carter argument is it's trying to draw a conclusion about essentially which percentile the Earth falls in terms of this timescale for life to evolve, when we only have one data point. And this is the problem with almost all, this is not the first time that people have tried to do this. This is not the first time people have tried to make statistical assessments to assess the probability that life exists. The most famous is the Drake equation.
Yeah.
Which tries to summarize all of the different components required for the formation of life, and then make a loose estimate, a back-of-the-envelope calculation as to how many alien civilizations there should be. But the problem with all of these arguments is we only have one data point. We don't know whether the Earth is incredibly unusual or absolutely statistically average. And anyone claiming that we can make an assumption that the Earth is average or rare or whatever is flawed, is wrong in making that assumption. It doesn't matter how hard you look at it, you can't fit a statistical distribution to a single data point. You just can't.
No,
And
that's right. And the no, sorry, you carry on.
well, I was just going to say that the one of the key assumptions that they make is that the probability of life forming at a timescale much shorter than the lifetime of the sun is vanishingly small because of the fact that it took 4.5 billion years for intelligent life to form on the Earth. But we don't know that. We don't know that the Earth, the Earth might be very unusual in the opposite respect. It might be one of the rare planets where intelligent life doesn't form within the first billion years, and we have no way of knowing whether that's the case or not. And
Yes, I think
the
that
other
goes to the core of the assumption of the paper, right? Which is that it has this this Carter argument, and then it later on they make like in order to put in the parameters to the Bayesian analysis, they have to come up with numbers essentially to describe how likely a certain thing is in this particular sequence of events. For example, one of them is the development of what's it called? Eukaryotic. I can't remember. I can never pronounce that word. Do you know the word I'm talking about?
eukaryotic.
Eukaryotic life,
Yeah.
which is, as you say, we can make estimates based on Earth, which are themselves quite circumspect, shall we say? But to draw any conclusions about any other planet, I mean, I guess the question, of course, or the question that might arise is that, well, you know, we can, using telescopes and various kinds of analysis, infer about certain things about other planets. So why is it so unlikely that we wouldn't be able to infer the nature of, say, the atmosphere and the temperature of an exoplanet, and therefore draw conclusions about its similarities to Earth? And I don't know, like, what are the limits there?
Well, we can start to do that, and I should point out the caveat that this is a field that neither James or myself work in, although we have both worked with people who do this for a living at various times. But we can start to do that. We can look out with powerful telescopes and we can observe planets, and we can even start to map out their atmospheres and determine whether or not they would be capable of supporting life. But there are huge limits still in what we can achieve. The science of finding and studying exoplanets has really, it's accelerating incredibly rapidly. It's amazing achievements have been made.
Yeah.
And for a long time, it was assumed that the existence of rocky planets outside of the solar system was rare because when we looked out into the rest of the universe, the only planets that we saw were so-called hot Jupiters, which were very large gassy planets like Jupiter that orbited very close to their host star. But some of the people who were a bit more on the ball about this pointed out that the reason we were observing hot Jupiters is because they're the easiest things to observe.
Yes.
And this is a big problem, is that the limitations on our instruments mean we have a huge sampling bias where certain types of planets are much easier to observe than others. And we can try to adapt for that, and there are lots of people who do. Lots of people who are far more intelligent than I am, who spend their lives determining what the sampling bias is for these exoplanet detection systems. But the problem is you can't correct for a problem in a statistical distribution. You can't correct for something that you don't know is there. So we can correct for sampling biases that we're aware of, but we can't correct for sampling biases that we don't yet know anything about.
No.
And yes, we've discovered a lot of exoplanets now, an awful lot, but we've still only discovered really a few hundred exoplanets that are very, very close to us in space. We only know about the tiniest little pocket of space around our solar system.
I guess the other issue is that the problem is compound, right? First, it's having the technology and the understanding to be able to infer the nature of the environment on other planets to a sufficiently precise degree to be able to sort of begin thinking about how life might evolve on those planets. Mm-hmm. And then, furthermore, even on our own planet, the understanding of the development of life on Earth is it's come on leaps and bounds, I'm sure, in recent decades, but it's a difficult thing. I think there are still some
Yeah.
pretty core. I think they even mentioned in this paper a couple of core sort of. I can't remember what word they used to describe them. Paradoxes, which remain unresolved vis-a-vis the creation of life. I think one of them is this notion of eukaryotic life, the idea that how did eukaryotic life come to be? How did the encapsulation occur?
And it's interesting, actually. One of the things, I guess maybe this brings us on to the next major point of criticism for the paper, which is that it suffers a lot from an anthropic bias. So there's a problem in looking at a system that has certain restrictions on how you observe it and drawing conclusions about how average that system is. So a classic thing would be a classic argument that might have an anthropic bias is something that says like, oh, well, Planck's constant has the value of 6.626 times 10 to the minus 34. It could have any value. Who's to say that Planck's constant has to have that value? So, there are infinite possibilities for what Planck's constant could be. And that means that the universe as we understand it was very unlikely to form. But the problem with that argument is you wouldn't be able to make that argument if the universe hadn't formed.
Yes.
So yes, you might be able to say, oh, the probability of Planck's constant being this was very small, but it has happened that way. So now the probability that Planck's constant is 6.626 times 10 to the minus 34 is 1.
Yes. I would also say that it assumes that the likelihood of all the other numbers that aren't Planck's constant being Planck's constant are equal, which is...
which is also flawed.
Why would you say that?
I know, but it's an argument that people genuinely make, especially on the Big Bang Theory, which is just, wonderful place to look for valid science. But the where the anthropic bias problem comes in here is one of the core assumptions of this paper is that life in the rest of the universe works the same way that it does on Earth.
Yes,
and that's because the only example we have of life forming is on Earth.
Yeah.
So, but we have no idea whether that is a valid assumption. Again, Earth could be incredibly unusual, and the way that life has formed on Earth could be incredibly unusual. And one of these things, the thing you pointed out about the development of eukaryotic life, this is one of the big mysteries in our biological history, because when we talk about in this paper, they talk about these critical steps, these critical evolutionary steps, which are required for the formation of intelligent life, or so they claim. And a lot of emphasis is put on the formation of intelligent life, like humans. But if we actually look at the timeline of the history of the planet, the Earth formed about 4.5 billion years ago, and for about the first 500 million years, it couldn't support life, because it was under constant bombardment from asteroids. The surface was a blasted hellscape, and there was no atmosphere of any appreciable kind.
That does not sound like a fun time.
No, indeed. Hence it's called the Hadean, which is quite appropriate.
Yeah.
And then from about 4 billion years ago up to about 500 million years ago, the only life on the planet was prokaryotic, single-celled.
Yes.
Or for most of that time, rather. It was single-celled. And then we have the emergence of these eukaryotic cells that are fundamentally different and involve lots of different organelles all working together in a sort of hive organism, and then that compounded. I'm very sorry if you're a paleobiologist and you're listening to this. I know I'm butchering it, but this is my understanding. Then those eukaryotic cells combined into multicellular organisms, but that only occurred about 500 million years ago. So by far, if we take this idea that we can just look at time periods over which different processes occur, and if a time period is longer, it's less likely, then by far the most difficult step was forming multicellular life. And after that, things kicked off pretty fast.
Yes.
In geological time, I mean, we went from the first multicellular organisms forming to having intelligent creatures that can transform their own planet in the blink of a geological eye after that.
I think it's also worth identifying that definitions of life are the definition of intelligent life that they're using is quite, well, as you say, by the what did you call it? The anthropic
bias.
By the anthropic bias is fundamentally narrow. It's interesting. I was listening to, or I was reading again about the terrifying thing that is BSE or prion diseases, and thinking it's kind of prion diseases are one of these really pushes the boundary of what is the definition of alive, because it's. And I'm not proposing that this should be included in the definition for this study, but it's just for purposes of discussion. A prion is it's what it is it's a disease which is propagated or is caused by proteins that fold in a particular way. But what's interesting about them is that they will cause other proteins to fold in the same way, misfold, in the same way as themselves. Obviously, a protein doesn't have any sentience. It can't be said to be, making a conscious choice. But then, of course, neither does a bacteria. But a bacteria, has a set of kind of quite complex biochemical processes that go on that define its existence and complex mechanisms that are employed in different contexts in order to leverage itself into reproduction. But a prion isn't even it's not even the protein itself. It's
a pattern encoded into the protein.
Exactly.
It's so extraordinary.
And so it's I like to say, getting a prion disease is like being infected by triangles. It's like just you're getting killed by geometry. It's utterly terrifying. But it does go to kind of identify that there are the limits of what you can reasonably call life. And I'm not saying that prions are alive, but no. I think it illustrates the point that there is a broad range of things that you could include in your definition, and to suggest that intelligent life is that which is represented by what exists on Earth is quite an assumption.
I always think a prion is kind of like a computer virus, really, because if your computer's infected with a computer virus, it's not that silicon transistors have invaded your computer and attached themselves to it. It's that a pattern is being encoded into the existing hardware, which causes it to malfunction.
Well, I mean, it's information.
But the pattern doesn't exist. The pattern doesn't actually exist independent of the host.
No, that's right. I mean, it's
a virus or a bacteria, like a biological virus or a bacterium, is something that exists independent of its host, but a prion doesn't.
Yeah, that's right. It's encoded information.
I got a bit distracted there, but
no, that's
prions,
right.
Prions are so fascinating.
Nice,
as you say, it shows that life takes a lot of different forms. And one of the other assumptions in this paper, which plays into this anthropic bias, is that they assume that the formation of intelligent life, i.e. us, was the end result of a linear chain of evolutionary steps. And this plays into a very outdated... I'm sure that assumption was made in good faith as a way of approximating a very, very complex problem. But it's interesting because that way of looking at evolution plays into a very, very outdated picture of what evolution is.
Yeah.
The old ascent of man picture, where we have this idea that evolution was a linear process that goes from primitive to advanced, and that human beings are at the pinnacle of it. And that's just not true.
No.
Evolution is random variation, and any branch of that evolutionary process can prosper and survive and develop in any direction. And evolution doesn't make value judgments about things like intelligence.
No, that's true. I mean, I guess, the way to view it is that evolution leads to, well, I mean, anything more complex than the interpretation that was originally put forth for evolution, which is that it is natural selection. It's, the process of natural selection, leads to, over time, a particular species, although that is in turn quite vague in sort of modern definitions of evolution, to be able to survive the best. That's it.
Yeah. And I mean, evolution is one of those. It's such a powerful idea, but it's also probably one of the most abused ideas in science, because as you say, Darwin, in The Origin of the Species, didn't expound anything more than this very beautifully simple idea of natural selection.
Yeah.
But as soon as it was published, large numbers of people with political and sociological vested interests took hold of that idea and made it fit their own philosophies, the most famous of which was, of course, Francis Galton.
So I think perhaps we can look at the conclusions of the paper and try and come to some kind of conclusion of our own about this paper and its usefulness and whether or not they could have done something better.
Yeah, indeed.
I mean, I'll read directly from the conclusion itself because it's only a paragraph and I think it's worth listening to. So their conclusions are: it took approximately 4.5 billion years of a series of evolutionary transitions resulting in intelligent life to unfold on Earth. In another billion years, the increasing luminosity of the Sun will make Earth uninhabitable for complex life. Intelligence, therefore, emerged late in Earth's lifetime. Together with the dispersed timing of key evolutionary transitions and plausible priors, one can conclude that the expected transition times likely exceed the lifetime of the Earth, perhaps by many orders of magnitude. In turn, this suggests that intelligent life is likely to be exceptionally rare. Arriving at an alternative conclusion would require either exceptionally conservative priors, finding additional instances of evolutionary transitions, or adopting an alternative model that can explain why evolutionary transitions took so long on Earth without appealing to rare stochastic occurrences. The model provides a number of other testable predictions, yada yada yada. So I think that's that pretty much covers it in terms of what they concluded from their research. However, I think they actually pretty much identify the core problems of their paper in the conclusions.
Yes, indeed. They point out the fact that the things that would invalidate their conclusions are that they have been excessively conservative in estimating the lifetimes, the timescales that they're assuming are average, which we've discussed could well be the case because, as we've said, we only have one data point, and it doesn't matter how hard you try, you can't fit a statistical distribution to a single data point. Or that there are additional instances of evolutionary transitions. We've discussed the point that intelligent life doesn't have to be human-like. It doesn't necessarily even have to be multicellular. We know nothing about any other form of intelligent life other than ourselves.
Yes.
And the final point that we would need to explain why evolutionary transitions took so long on Earth without appealing to rare stochastic occurrences. Well, again, that is something that we would be able to explain if we had another sample of life occurring to which we could compare the Earth. But in the absence of that, we simply don't know. And they also point out, as you said earlier in the paper, that there are a number of points along this evolutionary road that they describe where we have no explanation for the timescale over which that occurred.
No, and also the assumptions of concurrent. They say in the conclusion here, adopting the one way of achieving different conclusions, they say, is adopting an alternative model that can explain the why the evolutionary transitions took so long, and their model, I guess in their model they assume that they're sequential, which is
fundamentally flawed. They're not. That is the basis of our modern understanding of evolution, is that it is not a linear sequence of events.
Yes.
Leading to more advanced life.
Yes, and when you remove that, the entire of their analysis breaks down. I think that pretty much covers it, really.
So in short, well, how do you want to soundbite the paper, James?
Yeah, I think this is just another example of something we saw before with our anthropogenic mass paper, which is that the intentions of the people writing the paper, I'm sure, were pure, and the analysis they've done and the assumptions that they've made are not inherently wrong, because you can as long as you state your assumptions and you perform your analysis correctly, and then the conclusions that you draw, or like the results that you have, are correct because the analysis you've done, assuming those particular assumptions, is correct. There's nothing inherently wrong with that. And if you look at their conclusions, as we've just seen, they go out of their way to identify that if you were to assume different assumptions, or take different assumptions, or use a different model, then you could get a different answer. The concern is that the title of the paper is "Timing of Evolutionary Transition Suggests Intelligent Life is Rare." That doesn't gel with what they've written in the paper, and it's just I don't really see. I guess it's a twofold problem. It's first that the paper has been advertised through its title and also its abstract slightly to be something that it isn't. But furthermore, because of that, the media has then picked it up as being something that it isn't, and it creates this kind of snowball effect where you end up with something which is quite conservative in its actuality, in its statement, in the paper. When you read the conclusions and everything, they go out of their way to make clear the assumptions and the caveats. But when it's been rolled out on the press or to the wider world, that just gets lost completely.
Yeah. And it should be pointed out that when science enters the public sphere, it often ends up being distorted based on people's previous prejudices and assumptions. But one of the key skills that you're expected to develop as a scientist is the ability to anticipate that. And of course you can't control what someone else writes about your work, but you can, through your title, through your abstract, try to at least place some control on that. And I don't know whether it's deliberate or not. I mean, everyone just tries to frame their research in the best light possible, but I feel like this paper was almost courting controversy.
Yes. I mean, if I'm honest, I actually disagree that, like, when you read the actual text, the content, like, of the paper, we haven't read it now, but, they're quite explicit about their assumptions, right? It's not like they're trying to obscure the assumptions that they've made. And the method is quite, again, explicit. And the conclusions that they draw, whilst the assertion at the top of the conclusion is, in my mind, too strong, where they say, together, was the actual statement. This sentence here. In turn, this suggests that intelligent life is likely to be exceptionally rare. Now, that statement, if you take it purely in the context of the previous analysis, so you say if you prepend that sentence with, given all of these assumptions, our analysis implies life is exceptionally rare, and that is a true statement.
It is a true statement, but then they title the paper. The timing of evolutionary transition suggests intelligent life is rare.
Yeah, no, that's true. I guess I guess it's the I don't know.
It's not titled. It's not titled a Bayesian analysis of evolutionary transitions assuming an Earth-like case, or something like that.
That's right. No, that's true. I guess I'm just remembering times that I was in the room when we'd written a paper and the person who was responsible for having the final say on what the title was going to be was happily waxing lyrical about imaginary monsters that we seem to have discovered, when in fact there was no such thing.
What you're talking about.
And so I guess all I want to do is make the listeners aware of the fact that it's not, the writers on a paper are not a monolith. And if I had to suspect what actually happened here is that, some poor PhD / postdoc was given the task of actually doing the research, which they did reasonably well. Like given the context, like the obvious kind of framing of the paper, the original question of the paper, because you can't really come up with precise like numbers on things like the quantities that we've described. But then, at some point down the line, they were like, "Oh, let's put this as a jazzy title," and boom, there you go.
And the thing is that not to cast aspersions on specific people, but two of the authors of this paper are from the Future of Humanity Institute at the University of Oxford, and the Future of Humanities Institute has form when it comes to reporting very radical conclusions from extremely limited data. And as you say, the analysis here is actually quite sophisticated, but the FHI have most famously reported to a number of different news outlets at the same time, made a press release stating that the probability that human beings will be made extinct by 2050 is 10% or something in that region. And the methodology that they used to come to that conclusion was laughable.
Yes.
Not just flawed, unbelievably ridiculous and laughable. And they also compounded the problem by keeping their methodology extremely secret and not discussing it openly with the media outlets to whom they reported it. So I'm sure that you're right. The authors are not a monolith, but the hand of the FHI in this paper makes me more inclined to view it as, I don't want to say anything libelous. I think the FHI has made a bit of a habit of exaggerating their conclusions to get in the news.
Yeah, I mean, I don't disagree.
This feels a bit like that.
Yeah, I don't disagree with that. I don't disagree with that at all.
So maybe it would be interesting just to quickly, for the as we move towards the end, just talk a bit about SETI, because it's one of the biggest questions in science, and every scientist from here to Tohoku University has an opinion on it. So
yeah, well,
what are our
interestingly, they had a bit of a SETI moment, as happens every sort of like 2 or 3 years, where they say, "Oh, we've detected a signal from." I think actually recently it was a signal from quite close, right? Wasn't it Proxima Centauri?
This is that was quite an exciting point. It something that appears to have hallmarks of an artificial signal. I mean, of course, the caveat exists that this is far from the first time that such a signal has been observed.
I should point out that it's not. They don't just SETI doesn't describe such measurements as artificial signals.
No.
They describe them as anomalous signals. Well, I don't know if that's the exact language, but what they mean, to be considered as something worth investigating is something which does not fit an existing pattern where we can explain it by other means, essentially.
Yeah, exactly. So it's an unusual signal. It's emerging from a system where we're pretty sure there's a planet. Isn't it? It's coming from Proxima Centauri, isn't it? Did you just say that? I did
just say that.
Sorry.
How dare you.
So it's a system where we're pretty sure that there is a planet, so it raises a very interesting question. There have been many such signals that have been anomalous and then have later been explained as something completely natural, but the fact there's a signal in the past has been explained as natural does not mean this one will be explained as natural. That is indeed the gambler's fallacy, and we shouldn't fall into it.
I guess what's interesting to think about when you're talking about SETI, because we should describe what SETI actually is. I mean, SETI is a program of using radio telescopes to listen for signals coming in from the wider galaxy / universe. And sort of ascertaining whether or not those signals come from intelligent life. The equivalent would be some kind of radio transmission occurring from an alien planet. I think what would be interesting to think about is what are the problems with that model? of alien
Yeah.
detection? What assumptions does it make? I mean, the first one I'll start is that, it doesn't make this assumption, but it relies on the fact that, alien species, if they transmit continuously for reasonable periods of time. Because I think one of the more common sort of theories about development of civilizations is that there's actually typically a very short window where they broadcast unidirectional radio transmissions.
Yeah.
For the reason that it's just inefficient. There are more effective ways of transmitting data. One is through, fiber optic cables, and if you have to do it through the air, through directional sort of coherent radiation beams, lasers.
Yeah, why would you waste all that energy by pissing it out into space?
Exactly. So it sort of creates this, you can imagine a civilization, if this is true, which it's quite reasonable to assume that it is, then the radio waves or the sort of the time over which they transmit radio waves in a unidirectional manner is quite short, and what you end up with is a kind of shell of information that expands from the planet in question out into all directions in space, and that shell is incredibly thin. At the order.
And if you don't happen to be looking in the right direction when it passes you, you'll miss it.
Exactly. So if that's true, something, a planet there could be aliens on Proxima Centauri, right? And which is the closest star to this star. Not on the star, obviously, on the planet that is orbiting around that star.
Yes.
Although, I mean, the idea of aliens that live in magnetospheres of stars is not completely outside the realm of possibility. It was the subject of a great science fiction book called Sundiver. Anyway, I mean, if the idea, I don't know what this is called, this idea that there's this hollow shell of information. I think there must be.
I've heard it given a number of different names. I've heard it called the lighthouse model is one thing, because it's analogous to a lighthouse beam sweeping past you, and if you aren't looking at it when it goes past, then you would never know that it was there.
Yeah, and so the idea is that there could be an intelligent civilization of aliens on Proxima Centauri who just came to prominence a few hundred years before we developed radio detectors, and have since been happily going about their business using directional transmitters.
Of course, there's also the possibility that the majority of civilizations that are advanced to the level that we would call them intelligent don't last for very long. Either they go extinct or they don't continue in a way that we can recognize them.
Yeah.
I think I think it's very probable that humanity will look nothing like it does now in even a few thousand years' time.
Yeah.
If that is, we survive, of course. But with the way our technology is developing, if we are to survive the next 1,000 or 2,000 years, I don't think there's any reason to say that we would look and behave and transmit data in the way that we do now.
No, and one of the great problems with this sort of thing is just, and it speaks to the paper that we just talked about, which is that it's incredibly difficult to put yourself, in the mind of a non-human species. Yes. I mean, I guess there's other I guess you can imagine, many of us have pets, and sometimes you can anthropomorphize pets, but the key word there is anthropomorphize, to really know the mind of your dog, to really to step back and say, well, actually all of those reactions that it's having aren't really thinking like a human.
Yes.
Because there's no reason to believe that that's the case.
Yes, why would we believe that alien species want to communicate using a long distance communication network? Why would we assume that they would encode information in those signals like we do? We're assuming that if we observe a signal that's switching off and on and looks like binary encoded information, that it will be artificial. But how do we know that they don't encode information in polarization, for example, which we are not searching for?
One of my
also, things like the reason we use radio waves is because there's a radio window in our atmosphere where absorption is very low. But even relatively small variations in atmospheric chemistry could fundamentally change that, and alien species may use different frequencies.
Yes, I quite like the idea as well of, this notion requires that intelligent life develop technology, right? This, harness whatever it may be to sort of create signals that you can amplify to the strength such that it can, cross distances of interstellar differences whilst maintaining a sufficient intensity such that it can be detected at the other end. Whereas, what if this intelligent life is slime mold, but slime mold which has developed,
intelligence.
Exactly. I mean, there's really no reason to believe that's not the case. Like
Well, we know of hive mind systems that exist on Earth.
Yeah.
So that is clearly a valid route towards intelligence.
Yes, and again, pointing back to, making reference back to the paper that we talked about. Their definition of intelligent life is so
very
reductive
narrow.
That it's borders on point, completely meaningless. I mean, I guess you could say, like, really, what they're saying is, we've done a calculation.
The chance of human beings existing elsewhere in the universe is very low.
Like, Stargate would like to hear, maybe they haven't included the possibility that an ancient race of Goa'uld seeded other planets with humans. Which
it's not going to be like Star Trek. We're not going to go out and just find a whole bunch of bilaterally symmetric four-limbed people with bumps on their foreheads.
No, that's true.
Which I think that is a fair conclusion. If that's their conclusion, then I'm totally down with that. Yeah. But life is incredibly diverse, even on this planet.
Yeah.
And assuming that it would look the same everywhere else and follow the same rules is just fallacy. And, I mean, there are reasons to... I've noticed recently that there's been this decided shift, where it used to be that the standard... assumption that most scientists made was it's almost certain that intelligent life exists somewhere else in the universe and we just haven't found it yet.
Yeah.
And I've noticed over the past few years that that's shifted, and maybe it's part of this kind of pessimism of our age, that it's quite attractive to people to believe that we're alone in the universe. But I don't think that there's anything in the science that's changed to make people draw the opposite conclusion. We haven't advanced enough in our understanding of things like abiogenesis. We don't have any more information now, really, than we did 10 years ago when everyone was busily expecting aliens to be right around the next rock.
No. Just as a slight side note, I like the idea that we could set up a new SETI that uses gravitational wave detection.
That's an interesting thought.
Because obviously, that no one's going to be, booking time on the what's it called, the device they detected the gravitational waves.
LIGO.
No one's going to be booking time on LIGO to listen for aliens, but the notion that they're looking at building a bigger one in space, which I think is really cool. And so LiDAR basically. Well, we can not LiDAR. That's what I work on.
LIGO.
LIGO is a device. It's actually 3 devices in America, which are used to detect waves, ripples in space-time caused by the movement of large objects very, very far away, and it's fascinating. I think, was it the previous Nobel Prize was awarded for the discovery of gravitational waves or the measurement?
I think it was. Yes, I think it was last year.
And in my mind, it was amazing. It's one of the great discoveries in science, really, on a par with
it's extraordinary.
Just truly amazing. But this notion that perhaps there's a group of or a species of alien that are developed to the point where they can, manipulate matter on a sort of solar system level, and are somehow,
or just that they, that gravitational waves could even be a method of communication. I mean, it's one of the things that bothers me about this whole discussion, this very pessimistic discussion, is it seems to require quite a high level of arrogance. we assume that, oh, well, human beings have developed the best way of communicating. We've developed the best way of colonizing space. We've developed the best way of encoding information, and no other species in the universe could possibly do it differently to us.
Yeah.
And we don't know that. Maybe once we understand more about gravitational waves, we'll realize, oh my God, why did we ever use electromagnetism to communicate? Obviously, gravitational waves are better.
Yeah.
We just don't know.
No.
And to put on a tinfoil hat for a second, because I feel like we have to a little bit, given the subject matter, but one of the kind of grander scale things that has been done with SETI is trying to look for galactic scale evidence of life. And the theory basically goes that if you assume that there have been stars that are similar to the sun, that could potentially support life similar to how we understand it, some of those stars have been around billions of years longer than the sun.
Yes.
And if life emerged on one of those planets, then it would have intelligent life. Then it would be billions of years older than us, and billions of years potentially more advanced, quote unquote, in terms of technology. So we would expect in the universe for there to be at least a few galaxies that show signs of galactic scale civilization.
Mm-hmm.
And there was a study a few years ago where they looked at the Hubble galaxies in the Hubble Deep Field, and they looked for evidence of any kind of distortion of its spectrum, or any kind of distortion of it's an EM spectrum basically, that might be evidence of aliens harvesting energy from black holes.
Yep.
On a massive scale, or energy, or building billions of Dyson spheres or whatever. And the conclusion from the paper was very odd, because some newspaper outlets reported it as, we've discovered intelligent life because some galaxies had weird signals that couldn't be explained, and other outlets said, oh, we've proven that there's no such thing as intelligent life. But the question I always wanted to ask the people who did that study is, how do you know that every galaxy you observe doesn't have something weird going on? Because if every galaxy had been modified, you wouldn't know, would you?
No, that's right.
And there are so many things that are weird about galaxies that we don't understand. Like, there are a number of galaxies that have been observed in the last 2 years that just don't seem to have dark matter, and we have no idea why.
Yes, which is
and no one's talking about that in with respect to SETI, and I'm sure that astrophysicists and cosmologists have their ideas about why that's the case, and that alien life is way down the list of possibilities, but it should at least be part of the conversation.
Yeah. Cool. Well, I think that's a pretty good overview of why that paper was flawed, and some of the more interesting topics in SETI and the search for extraterrestrial life.
Indeed. Well, I mean, we can just cross our fingers that in a week's time we'll both look really stupid, because we'll have had this conversation, and then aliens will have landed by the end of next week. And
we won't look stupid. We'll look
no,
right.
Yes, indeed, we entertain the possibility.
Yes, we did.
Or maybe, God will show up and say, there is no such thing as aliens, and then vanish in a puff of logic.
We should probably also include the possibility that the writers of the paper are in fact aliens and are trying to hide their existence.
Now there's a theory. Yeah. Yes. Gosh, that puts a new spin on things.